Hello, good morning everyone. Hope we are all doing well. I am Dr. Hikma. Today we are going to discuss about our uh, subject. Today is about the telecommunication engineering principles. So, as you know, nowadays telecommunication has a very important role in the exchange of information, which is very important for the development of each and every country in this world. Okay, so without delaying, you see the course outline. Here we have for the course outline details, we have the course plan which is already provided, and here we have the method of evaluation. Here we have the what we call the test will be 20%. We have the project which is cooperative learning 10%, quizzes 10%, assignment tutorial 10%, and the final exam 50%. This will be our method of evaluation so far. Okay, so now the first part of our subject is communication systems. Also, we have three topics to discuss. We have introduction, which includes the terminology and the definitions. We have a mode of communication systems and the digital information. So the learning outcomes, meaning at the end of this topic, your students should be able to differentiate the terminologies such as telecommunication, communication, data communication. Also should be able to explain the different modes of communication systems, and also should be capable to comprehend or apply and analyze the relationship between analog signal and their digital representation, so in a various digital format. Okay, now we have this various terminology and definitions. As we see, as definition, we have a communication, which is a transfer of information from one place to another. Communication. This include the telecommunication. This one will involve the distance, meaning we exchange data from quite far, from one place to another, which are a bit far located from each other. So communication systems provide electronic exchange of multimedia data. So example of multimedia data, we have a speech, we have a music, images, video, data, etc. So telecommunication systems today, so which this one include the radio and the television broadcasting, we have a fax, a modem, we have a cellular, mobile phones, computer networks, satellite systems, etc. So part 2, we have a mode of communication systems. So in this one, we have generally we have 3 mode of communication of data exchange or data transmission. We have what you call the simplex transmission. In this case, as we see, the data will be flowing in one direction. Yeah, only one direction. The channel provided will only use for sending the data only. Okay. So after this, you have what you call the half duplex transmission. So with that, maybe I have to make some clarification. For the simplex transmission here, if you want to send and receive data, we need to use 2 channels normally. One channel is for sending data, another one for what you call sending back the reply. So we have the half duplex transmission. In this one, we have both transmission, stations may transmit, but only one at a time. So we have a one channel, but only two stations will be transmitting one at a time. The sender will transmit, the receiver will be waiting. Once the receiver receives something, want to acknowledge or to send back, then will be allocated the time to reply back using the same channel. And we have what we call the full duplex transmission. In this one, we have both stations may transmit simultaneously the same channel. So the stations transmit and they receive at the same time. You see the difference, eh? Simplest transmission, one channel for transmission. For replying back should be a different channel. Half duplex, one channel, but each station should allow to send once at a time. Send and they wait at the other side, give feedback, and so on. For the full duplex, at the same time, simultaneously, send and receive. So at part 3 is digital information, and this one we need to see how we have the transmission, what we call the conversion of analog signal into the digital signal. As we know, the analog signal is just the signal that is continuous with time, up, down, no break. Also various, the signal varying with time. So the digital signal is having like a what you call the peak value with up and down, 0 and 1, 0 and 1 regularly, and so on. So how to convert the analog signal into digital? So here we have three steps normally. The first step is called the sampling of the analog signal at a regular interval. So it's a division of the analog signal into a regular interval. So that one is called sampling. So each interval is quantized or assigned a value. We give the value to each interval. This is called the second step, which is quantization. So the last step is just we have to map the quantized data into its digital equivalent, or into the binary equivalent. So for instance, here we have the first interval is quantized with the number 7. So number 7, we need to convert its equivalent into binary. So we have 1, 1, 1. The next interval is 3. So the equivalent in binary is 0, 1, 1, and so on. So at the end, we collect the digital number, which is 111, 0111, and so on, to represent the analog signal into its equivalent digital signal. So that is all for now. At the end, normally we'll be having some project. So if you have a questions, it's time for you to ask questions until the end. See you maybe next time.